Good afternoon to all of you. This video intends to demonstrate a simple lesson in chemistry. As we all know, chemistry is one of the specialized subjects for senior high school. So I will take General Chemistry 1 and it served as my demonstration or teaching demo for applying each position. So first of all, I am Christopher G. Reyes, a chemistry teacher for almost 26 years. I taught chemistry, physics, mathematics, physical science, personal development, research in science, and other allied science subjects for secondary and tertiary levels, respectively. Now, I want you to focus on the subject Chemistry 1 under Science, Technology, Engineering, and Mathematics strands because there are many tracks or strands for senior high schools. ABM, gas, I mean general academic strands. Then we have Tech Book, then we have Marine Engineering, and of course, STEM is one of the subjects is chemistry. Now, how do we define chemistry? What is chemistry? Chemistry is a branch of science that deals with the properties, composition, and structure of substances. But what are substances? Are they the same as matter? Yes, these are all called matter. And in chemistry or in science in general, when we say matter, it is anything that has mass and volume, or simply anything, everything around us which contain or occupies space and has mass is called matter. Example of substances, we have stone, air, wood, paper. How about God? As long as this is an object, invisible or visible things, tangible and intangible things, they're considered matter. Now, let's focus on the example paper. Paper. You know what is paper? This is an example of paper, a piece of paper. Now, I want you to tear a piece of paper. So I have here a piece of paper. So I want you to tear this. Okay. So if you're going to tear this paper into bits of paper, look at that, bits of paper, all right, you will notice that there is what? There is a change in size because the original one is big. But this time after tearing the paper, all right, you have small piece of paper. But the most important here, you have still bits of paper. Okay. Now, is there any change? There is a change because before there is a big size or the paper before tearing it is a good condition. That's a good condition. But this one is no longer in good condition. So, but it's still a paper. And this is now what we call the changes in matter. And of course, there are three changes in matter. First is physical change. Physical change is a change that matter undergoes which does not alter the composition. Look at the definition of chemistry. Does not alter the properties, composition, and structure of the paper because it's still a paper. You only have bits of paper. Okay. Number two, but if you're going to burn this, okay, get a box of matches, you burn this. It's no longer a paper, but you have a new product, and that is your ash. Now, ash will tell you that the paper turned to ash, and that is chemical change. Now, remember physical changes in matter undergoes a change in size. Size. While ago, there's a big paper. Before we tear the paper, of course, the size is in good condition. Shape. Is this the original shape? No. And face. Is this the original face? No. But the particles do not change because you just tear, you just rip the paper. And also, mixtures experiencing physical change. Next, chemical changes. Chemical changes, particular particles of one substance are changed in some way to form particles of a new substance that has a new and different properties. After burning, you have ash, correct? Paper and ash is not the same already because we have a new substance after burning the paper. So that is chemical change. There is a what? Reaction between the heat. Burning is a combustion process. So there is a production of gas, smoke, in the form of smoke, or ash. Heat or light is also present. And is a ash solid? Yes. Now, another example. We have here the three types of changes matter undergoes. All changes in matter are classified as either physical changes, for example, the freezing of the water, ice, this and formation of ice. If you burn the wood, It's a chemical change. There is atomic bomb, okay? Atomic bomb in Japan, in Israel, for example. That is nuclear change. Formation of gas. The clouds. It's a nuclear changes. Before there are only two, but because of the new discovery, nuclear change is also a form of changes. It's one of the forms of changes. Okay, another one. We have mixing of chemicals. Okay, these are examples of chemical change. Mixing of chemicals. What do you think is the substance in green color? For example, the copper sulfate. Then you add blue color, let's say dye. What will be the reaction? Blue and green. Blue green. Blue green will be what substance? Yes, copper sulfate. Then cooking. Of course, burning of food. What about this? Firecrackers explosion. Yeah. This is chemical change and this is nuclear change. Now, what are the three changes again in matter? We have physical change. How do you define physical change? Physical change is a type of change that does not alter the properties, the composition, and structure of substance. Chemical change is the second type of change that alters the properties, the composition, and structure of a substance and produce a new product. The word a new product there, okay? Now, I will give you simple exercise. Okay? Identify the types of change. Evaporation. What will be the answer? What type of change does evaporation show? Physical. Why physical? In the evaporation process, waters change to gas or steam. And that steam is still in what substance present in steam? Water. Water droplets. Okay? Still water. Boiling process or boiling. If you boil the water, what did you boil? Water. If you open the kettle, what do you have? The fumes. The boiling water reaches the 100 degrees Celsius. Still water, correct? Physical change. But this one, digestion. If you eat from the mouth going down, but before it goes down, there is a reaction between the saliva and the molecules, large particles of the food you take in. And it goes down to your esophagus and to the stomach. What does it mean? There is a chemical change. Atomic bomb, okay, nuclear change. Firecrackers, still nuclear change. Rusting of iron, rusting. Iron plus oxygen. The iron is exposed to the atmosphere, and atmosphere has oxygen gas. So iron plus oxygen, chemical change. Okay? So, any problem? All right. So if you go back to the definition, so I will give you these three. So if you have any questions, I will give you assignment for next meeting. Give examples of nuclear changes occur around us. And thank you very much for listening. Bye.